You know, when we solve equations, usually we solve it and get x equals a number, or whatever the variable is equals a number. However, when we come to two variable equations that have an x and a y, say, the solutions to that, well, they're going to have an x value and a y value. And so that's one of the reasons why we talk about this rectangular coordinate system, which you may know by other names. But what it is, yeah, you've got an x number line or x-axis. Just go over this real quick. And then you have an axis or number line perpendicular to that, the y-axis. But yeah, those are just number lines, and positives here, positives up here, and negatives on the other sides, right? But that's what we mean by the rectangular coordinate system. And what that, again, just some more terms, that breaks the surface into four parts, quadrants they call them. You got the upper right quadrant, well, that's where they start with quadrant 1, and then using Roman numerals. Quadrant 2 is then you go counterclockwise, quadrant 3 and quadrant 4. I mention those because sometimes we do reference those. And so those are the quadrants, they're called. Yeah, the point where these axes all cross there, that's, of course, referred to the origin again, just some terminology. But yeah, so what we have is a way that gives us a way to label points in this system, and points are ordered pairs. Sometimes they're called, because they are prescribed a certain order, right? X, comma, y. So the x coordinate is first and the y coordinate is second. That's the order of the pairs. So for instance, 2 comma 3, that means the x is 2 and the y is 3. Like I said, probably a lot of you know this, but just so we're all in the same place here. Yeah, so that's how we label points, because yeah, that gives us, in this particular case, 2, 3, x is 2, and then the y is 3, and so where those things align there, that's the point, 2, 3, the name of that point. So it gives us a way to name each and every point. All right, so they say locate, sometimes they say plot points here that I give you. So you tell me quadrant-wise. All right, which quadrant would that one be in? 5, negative 3.
4.
Quadrant 4, yeah. Because you go out, the x is 5, and then the y is negative 3, so the y's here, the ones below the line are negatives. So yeah, we're talking 5 and negative 3 is that point right there, so quadrant 4. What about this one? What quadrant? Negative 1, 4.5.
2.
Quadrant 2? Yeah, they don't have to be whole numbers or integers, and you can do fractions. But yeah, so x is negative 1, the y is 4.5, so that would just be halfway between the 4 and the 5, so along about right in there would be the negative 1, 4.5 point. All right, 3. We have a trick question or two here. All right, where's that one? Is that one in a quadrant? It's not in a quadrant because that one's right on what? Well, the x is negative 5,
Yeah.
the y is 0, so it's on the x-axis. The origin is 0, 0. So negative 5 would be on the x-axis back here, wouldn't it? because it's -5 in the x, 0 in the y. So it's, yeah, it's between quadrant 2 and 3, but it's on the x-axis. For one on the y-axis, yeah, and you can have fractions. So if I plot 0, -10/3, probably you might want to change that to decimal, right? To see where that would be located. That would be, if you divide that, -3.3 repeating, so a little over -3, a little past -3, let's say it that way. So 0, -3.3, that would be on the y-axis, wouldn't it? Because x is 0, so you don't go anywhere for x, if you will. But then you go down to -3.3 repeating, but yeah, so that's 0, -10/3 is right there. Anyway, all right. So, like I said, me, have just been reviewing that, but just want to make sure. Okay.